sorry, we had the recording off. So, I've added these kind of bars, which I'm going to thicken a bit because it alludes more to Cosen's notation. And so, you could use other notation for this. I probably would use different notation for this, but I want it to be consistent with the book, so if you want to check there, or if you've already looked there, things are not confusing. Right. First level is still obvious, but like, I just want to like hammer home a couple points that I was making, which was, these are not, every box is not a, each box is not a variable. Each box is a set of variables. This example just happens to be a simple example where boxes are either the empty set or a set with one variable. So I'm not going to write the set notation other than to write empty set instead of blank, like, but what was I going to say? But yeah, but remember that these are sets, because I think that helps with the intuition in some sense. Okay, so the first layer is obvious because we're in Chomsky normal form. Everything is generated by, every terminal is generated by exactly one variable. You could technically, like you said earlier, have another variable making the same terminal. You could always simplify this and remove one of them. But even if you did have two that generate A, you would just have, instead of A, you would have A, I don't know, Q in each of these, if Q is also generating the terminal A, because they're all sets. But because we only have one variable generating each type of terminal, the first layer is very easy. But what the first layer is really asking is, it's posing a question that's going to change as we go up in the layers. It's saying, what set of variables can I use to generate the substring between the bars 0 and 1. And this one is asking, what can I do to generate the substring between the bars 1 and 2? When we go to the second layer, we're asking, what can I do to generate the substring between 0 and 2? But we can answer that question by looking at what generated the substring 1, between 0 and 1, and the substring between 1 and 2. Does that make sense?
Yeah.
So this checks the pair AA and says there's no way to generate this.
Right.
There's no so it's not like just a blank, it's the empty set. There's no variables that generate this.
Right.
Good. The next one is doing the same thing for the substring between 1 and 3, which happens to look at A and B and give us S. This is going to be blank, right, because BB can't be generated by the, I don't like blank, I'm going to keep using empty string. In Cosen, all of this is inverted and then like pushed down. It's the same example, but it's completely different orientation, which can be a little confusing. So for B to A, it's S again, right? And then same thing for A to B. Now, where we were getting confused next was this next layer, right? So this box is now going to ask about the substring from 0 to 3, about generating that substring. Now, it could generate that substring by either using, this substring can only be generated by this pair or this pair, right? Is there anything that generates just S? Is there any variable that just generates S?
No.
Is there any variable that just generates S and again, like nothing else? No.
Right.
So these have like a lot more reach than it initially appears, right? Like as you go up in layers, you're checking bigger substrings. Right. The reason you lose a box at every layer though is because, right, there's 6 interesting intervals of just length 1, there's 5 interesting intervals of length 2, et cetera, up to 1 interesting interval of 6, which is the entire string.
Right.
So, I gotta stop using blank, I really don't like it. I think it's unintuitive. Okay, this is now checking this substring, ABB, and asking, can you generate this substring in your language, right? The only way you could generate this substring, though, is from this pair or this pair, or is it this pair, I guess? I think it checks all. Yes. Yeah. And so do any of those pairs have variables that lead to them? Sorry, this pair or this pair? My bad. Is that right? SB. B.
We're generating ABB?
Let me check Cozen for a sec. Who has Cozen up? Thank you. Whew, these are the layers that get really nasty. Is once you start getting to these ones. Okay. So x1 to 4.
Well, yeah, ABB can be generated from C and from B, right? Because then you get SBB, or SB, and then S can also be AB. Then you get ABB. Does that make sense?
Yes, I believe that it. Right.
That's
Good.
the reason why
So
it's
you're checking all possible intervals that generate. Oops, did I move the camera?
a
No.
string. Okay, makes perfect.
So basically, we're looking. How can you generate? This is going to. I think I'm gonna. I wish I had like ID tags in each one because that would make it easier to visualize in some sense. So we're trying now to generate substrings of size 3. So we're talking about 1 to 4, right? What are all the ways you can generate 1 to 4? Well, you could do 1 to 2 and 2 to 4, or x1 to 3 and 3 to 4, right? It's one of these, so these are concatenated. But so let's look at x1 to 2. That's this, right? This is x1 to 2.
Right.
X2 to 4 is this.
Right.
So is there anything that generates an empty set? And the answer is no. The next thing you're asking is 1 to 3, which is this, and 3 to 4, which is this.
Right. And that
And that's
is
C.
yeah.
And that's where the C comes from. Does that, okay, that helps me.
Yeah, that's-
I would never have seen this from just his example. Like the things are too like skewed for me to have noticed this initially, I think.
The X notation is helpful.
I would love, I think like ID tags on all of these would be like nice. You could just even put like 1 to 2. You don't even have to have the X, right? You could just
Right,
have
right.
like a reminder for yourself. This is 1 to 3. Stuff like that I don't think is bad. So you could do that for yourself if you want while you're doing it. Anyways, okay, so we've gotten C. I'm going to switch to the new notation of just dropping the X because for consistency. Okay, this one is asking about the string 2 to 5, right? The ways to generate 2 to 5 are this and 2 to 3 and 3 to 5, right? BS doesn't have a generator. What about this and 2 to 4 and this?
No, because you can't get just 2 to 4 by itself.
Right, and those are our only options.
Right.
So empty set. The next one is going to be this and this. Yeah. 3 to 4 and 4 to 6. Doesn't make any sense, right? This is empty.
Right.
S and P, because this is 3 to 5 and 5 to 6, right? Because we're looking for 3 to 6. Those numbers help a little bit. This is going to be 3 to 4, but we don't have a 4 to 6. It's just not even a. Actually, yes, we do. Right.
Yeah.
This
S
is, you're right.
4 to 6.
No, yep, we do have all of them. Sorry. So we do have 4 to 6, but BS doesn't make sense,
Mhm.
and SB does.
Mhm.
It makes sense because you can do C.
Mhm.
Okay, next layer. I'm going to do this 0 to 2, 0 to 3. Okay, so now, it just gets worse every level. 0 to 4. Okay, so for the substring 0 to 4, we could do 0 to 1 and 1 to 4,
Yeah, we have S.
and that's S. Here's the key observation. We add S to this, we still have to keep checking all the other substrings, because these are sets of all things that could lead to this substring. Does that make sense? And that's why this methodology gives you all of the possible parse trees, not just a
Right.
single one. So
Right.
let's just go through it just to be extra careful. We know the answer from the example, but 0 to 2 with something else, we already know it's actually over, right? If
Right.
you get an empty string as one of your options, you can just move on, right?
Right,
Because
right.
we're in Chomsky normal form,
Right.
you should need to generate 2 variables. We're only going to check 2 boxes, and so if one of them is empty, we're not generating 2 variables. Does that make sense? So 0 to 2, throw it out. 0 to 3, throw it out.
Right.
0 to 4, possible. Now we need to look at 4 to 5, right? Which is somewhere. 4 to 5 is here. SA. Is that right? No.
I think you stuck on an extra one on the bottom right there.
What did I do wrong?
We're only looking up to the 4th.
0 to 4, 4 to 4 to 5. 0 to 1, 0 to 2, 0 to 3, 0 to 4. Oh,
We were checking.
sorry, you're right, I'm sorry. So, that's it, actually, yeah. I already checked 0 to 3. And that was the last one, because there's 0 to 4 is this.
Right.
Sorry, I moved on to the next one without thinking about it. 1 to 5. Cool, so this one was done because these two are obviously not true, and this one had one solution. Okay, so 1 to 5 is going to be, let's just start here and move up. So 1 to 2, and 2 to 5, right? I need 2 to 5, empty, done. 1 to 3, and 2 to 3. 1 to 3 and 3 to 5, is that right? SS.
Mhm.
What do we add? Does anything generate that rule?
S.
Okay, next is 1 to 4 and 4 to 5, CA, not generated,
Not a thing,
right? Okay,
yeah.
so we don't add anything for that, we're done. You can kind of just move up this row.
And like move down correspondingly on the right.
Yes.
Yeah.
Okay, next is 2 to 6. Let's start here. And then we need 3 to 6 to go with it, right? BC. Nope. Empty, done.
Right.
Right? Because
Right.
they whatever they pair with, it's just one variable,
Right.
so it's insufficient. Now we need 0 to 5 and 0, 1 to 6, and this is going to be 0 to 6, right? These IDs are saving me. 0 to 5, we go all the way up this. Okay.
We don't have AS.
So 1 to 5 is going to be what? What are we pairing this with?
S.
AS.
AS. Can we generate that?
No.
Nope.
Cool. Empty. These don't matter, right? 0 to 4 and 4 to 5 is
SA.
SA. Do we have a generating rule for that?
Yeah, D.
D.
Good, and we're done with that. 2 to 6 is going to be, sorry, 1 to 6. This looks like a really bad 2. A, and then 2 to 6, empty, done.
Right.
1 to 3 and 3 to 6, SC. Do we have a solution for that? Do we have anything for that? No.
No.
No variables generate that. C, 1 to 4. 4 to 6 is going to be here. CS.
No.
1 to 5 and 5 to 6
SB.
is SB. Right? Where's 5 to
Yes.
6?
And C does that.
Yeah. And can we generate SB?
Yeah.
C. Okay, 0 to 6 can only be generated by 0 to 5. It's 0 to 1 with 1 to 6. AC.
Yeah, that's S.
Okay. Still gotta do the others. Nope. 0 to 4 and 4 to 6. SS.
Yeah, that's also
Still
S.
S. Okay, this'll. Why is it not two S's in this box?
Because it's a set, so the same.
Yes. Perfect.
I have a question.
Yep. Can I do the last one first?
Yeah, go ahead.
0 to 5 and 5 to 6. We're almost there. I just want to be done. DC, nothing. Okay, we're good. That's it. It's all possible parse trees. While you were doing this, you can also be filling in. So notice when I did S, like, you could either do it before or after, but when I added that S, notice it was generating A and what? Well, what was the pair that generated S? It was, in the construction of the tree, it was 0, 1, and 1,
1, 6.
1, 6. So S must go to these two, right? We have one variable that leads to these two. We now know you can ignore this because this is the only thing that could have generated it, because something has to be higher in the boxes to be able to generate it. So we can work down from C, which, what did C come from? Like, this is the problem. You could we could have kind of done this while we were building. Like, DS came from what? I know we don't need D, it turns out, but D came from SA, which was 0 to 4,
4 to 5.
is that right? Okay. So you could have, if you'd been ambitious, it's a question of whether you want to add the arrows again later, like if you want to do this process twice, or if you want to do this, and then when you realize you're not going to generate it, just remove it. Right? So that's one way to go about it. The other way is to do what we're doing now, where we're looking back at our whole computation and doing it all over again.
Right.
Does that make sense? So like one will make your thing full of arrows and you'll have to delete half of them, well, more than half of them probably. The other way, we're basically redoing all of this, our work, or at least some of it, right? So for C, erasing this thing, let's just do it the backwards way for now, because we didn't do it while we were generating it, but I just wanted to note that you could conceivably do the arrows while you're making it. You just have to erase a bunch of them, because a bunch of them don't actually happen. Does that make sense? Cool. C was because of SB, which was 1556, right?
Yeah.
So we get there and here. So now all we have to worry about is this, right? These are done, right? These have gotten to basically where they're going to terminate, and we don't care about them anymore. S, and that's why doing it this way isn't so bad. Like if you do the arrows while you're going, it's really easy because you just follow the trails and erase everything you didn't hit with your from the start state. This way is also not that bad though, because you don't have to recompute the arrows for ones you never get to. Does that make sense? So S is because of what?
It's SS, because there's no C.
Yes, 1, 3 to 3, 5. Is that right? Yes. Okay, and then S is because of 1, 2, 2, 3, right? And this is because of BA, right?
Yeah.
Sorry, I need to put 2 arrows. Everything should have 2. Every variable should have 2 arrows, right?
Right.
If you don't have 2 arrows on a variable, it is a sign you're missing something. But now we're done.
Right. So this is a unique parse tree.
This is a unique parse tree.
Right.
But if it wasn't a unique parse tree, we would have had sets in all these boxes, which
Right.
would have made the computation more horrible,
Right.
but also been the only reasonable way to find all the parse trees at once, right?
Right.
Like this is a very nice way to find all the parse trees. It's just ugly because there could be a lot of parse trees and it's trying to consider a lot of things at once.
Right.
Sorry, you had a question and I talked for much longer than I intended to.
Yeah, I was just playing around with stuff.
Cool.
And I'll probably rewatch this because I wasn't like fully paying attention.
There.
But Kip, do you mind if I borrow the marker for a second?
Yeah, go for it.
I can write this on the side too. It doesn't have to be in.
After many, many takes,
In focus.
I think we finally got a decent one.
Yeah. Okay. So S. So what I did to figure out that the top was S, or like for
Yep.
these, is like S is A B B A B. So A B B A B, and then I know that A B creates S, so I get A S B A B, and then B A also creates S, so A S S B, and then S and S make S, so A S B, and then I know S and B creates C, or
Yes.
C maps to S and B, so I get A, C, and then A and C is just S. So that's how I went
Right.
about.
Yeah,
fitting
yeah.
things
The
in.
problem with this
is you can't find every single one, right?
yeah, and
Yeah.
look,
Or
think of
like
it,
you'd have to keep subbing in different
consider
patterns.
this problem. You are going through one potential parse tree,
Yeah,
and that parse tree might not even be right.
yeah.
Like if you'd subbed out a different AB with if you'd subbed out different variables with something, like for example, let's say
Sorry.
I think this helps.
you somehow
Yeah,
like
if you have
it
more
is
than
potentially
one,
possible
then
that you
there's
do
more
your
than one
method and
parse
you end up
tree.
stuck.
Right.
You end up stuck with
Right.
variables
I
you
don't know
can't
if it's
reduce
legit.
anymore.
Yeah.
So you end up with
We
like
just
3
say-
variables.
we just
and
count
there's no
the
way to
box
make-
with the
get them back.
maximum
So I
value.
just got lucky because it was
Yeah,
one
it's
person.
got to be like
Yes.
easily related to
Does that make
the
sense?
size of
Completely.
the
I realized that as you were explaining the last.
Right, and I think
One
that's why like I
sentence.
almost wish the example had sets. It would make the example more complicated, but it would
But make
tell
the
you
rule
why you're
clear.
doing all this.
I think that's the homework.
It is probably.
Yeah.
It's because you have to possibly, but like I wish the example in the book, in like Kozen's book, included some sets because even though it would be uglier, that's the only reason to do this process in
Right.
some sense, right?
Right.
Like you said, for this one, you just guess and check and it works because there's only one parse tree. So the only way to reduce it will work. But yeah, so for the homework assignment though, you'll have to be careful to make sure that every time you add a thing here, you check up all the. There can be as many variables in a square as the number of things below it. Starting here, right? So like this is always going to have 1. This will have at most 1, right? Because we check this. We stop considering terminals once we're here. This will have at most 2. This will have at most. Sorry, this will have at most 1. Is that right? No.
Yes.
Yeah, because it has to generate
It will.
two
No. It'll check at most 1 pair. That's the important difference from what I said. It'll check only AA.
Right, right,
But there could be multiple variables that generate AA
right, right.
by itself. So I guess what I meant to say more is that at this level, you should do 2 checks of pairs, right? And here you should do 3 checks of pairs, and here you should do 4 checks of pairs. But the pairs themselves don't even necessarily generate just 1 extra variable for your set here, right? Like I could have checked this pair, 0, 1 with 1, 4, and it could have given me like 3 variables in this set. The next one could give me 0, like this with its pair could give me 0, and this one could give me 2 or something, right? And then I could end up with a set of 5 variables up here.
Right.
So it can explode, but I doubt the homework assignment one will. Is just things to be conscious of that don't come up in this example, and so I don't want you to think about them on
Right.
the homework.
Right.
Because the homework, obviously, some of this is going to happen. Cool. I think we beat this to death.
Yeah, but like, if you guys have more questions to ask, like, go for it. I was gonna ask you if I could really quickly.
Talk about homework.
Talk to you about homework?
Yeah,
Yeah,
sure.
it'll take like 2
first,
seconds.
like you said, let's finish this up,
Okay,
and then
cool.
I'll stop
Sounds
recording.
good.
Do you guys have any more questions about this?
It's for me. It's more related to the homework.
Mm-hmm. Yeah. So what's the homework question
So
exactly?
the homework says to modify the algorithm to count the number of parse trees. So each time there's more than 1 variable, it generates a new parse tree, right?
So notice that the existence of variables in the boxes doesn't imply the existence of a parse tree that includes them.
Right.
So first you'll do the process that we did going up.
Yeah.
Then what you'll do is notice how I did 2 arrows from the top variable. Because those were the only thing that generated. So remember how I discounted another S? There was another pair that generated S, right? It was S and something else. 0, 4 and 4, 6, whereas SS.
Yeah.
So notice that I'm gonna dot them to separate them.
Can you
from-
do this recursively?
It kind of depends what you're recursing over. I'd have to think about it.
that's
Recursion is a
another-
very broad methodology, so probably I'm just give me a sec. Okay, so dots there, and then the other dots go to what? 4, 6? Yeah.
And so that's another parse tree.
No.
Why not?
That doesn't.
It's not another parse tree because is it another parse
I
tree?
think it is.
Wait, so S would this do we have valid? Oh yeah, I think it is.
S would generate
So let's do it
AC.
all. Let's do it all. S goes to AC. This goes to AB.
And then C goes to SB.
Yeah. And then B is 3, 4. Or not that
Nope.
B, the other B.
One
Yeah,
more.
you're right. Wait, which B?
One to the directly to the
3,
right.
4.
Oh, jeez. Wait, no. 1, 4 would be generated by 1, 2, 2, 4. No, sorry, 1, 3, 3, 4. Yay, sorry. Right, because then this generates these two again.
Yeah.
Okay, so one important observation now is that we don't want to make these sets. What do we want to make them? What do we want in the boxes? So why is there a second option for S up there?
Because
Yeah.
S has multiple.
Ways we could have gotten to it.
Yes, there were multiple ways to generate S. So why didn't, remember how I tried to store an S but it didn't work because I'm storing them as sets?
Mhm.
There's a term for sets that can have the same element.
Tuples?
It's multi-sets. Not tuples are ordered. We don't want to deal with that. Multi-sets are sets that can have the same element multiple times. So first things first, we should probably change these to multi-sets.
Right.
Right? We know that you have an option, if you have reached something from the start state, you have a valid way to continue picking any of the variables in this state. Right? That was true? Yeah.
So this means that we will be able to use D in some parse tree.
No, we never went to D.
But didn't we got to D from the ground up somehow, right?
Yeah, but you can't get to D from the start state.
Oh,
You can start with this string, and in fact, you can mess up what we were talking about by generating D. Because you can get to D from going backwards along here, right? So you also got lucky. Because if you made D, you couldn't have gotten to the start state, and you'd be screwed.
You can't make SA though.
What? I made A. With.
Oh wait. Oh, I see what you're saying. Oh,
Here.
because you could just. Oh.
I'm just saying, like, if you were working backwards, we know because D is here that there was a way to work backwards and grab it and get a D somehow, right? Is that true? Where did D come from? D came from SA, which was 0, 4, and 4, 5, right? Which
Yeah.
was SS. So yeah, you conceivably could have worked backwards from here, right? And gotten a D and then been stuck, I think. I'd have to do it out to
So
be
you
totally sure.
can't. You can use less than all of the indices. So you can use like 0 to 4 and 4 to 5.
0 and 4 and 4 to 5 to get 0 to 5.
Oh, I see.
Yeah.
Okay, my bad.
Does that make sense? It's always a pair that concatenates to become the string you
Yeah.
care about. So, if I store things as multisets, so I don't miss opportunities like this, how many parse trees are there? So here, how many parse trees are there? Let's start with a
2.
simple example. 2. Right. Because one set had 2 options, and none of the others gave us options, right? What if I had 3 variables here?
In 1 to 3.
Let's do an easier example, actually. What if I had 3 variables here in 4 to 6?
You'd have 3 parse trees? Or no, you'd have 4, sorry.
You'd have 4. Why?
Because you have the one we drew before, and then you have 3 instances of the secondary.
Yes. What if I
parse
put
trees.
3 variables here instead? Is that the same?
No, you'd have 6 because each branch makes use of it.
Yeah.
Or each tree.
Oh, both of the trees make use of that.
Yeah.
So
Potentially. Well, you're already in the state, so yes, yeah, because you got there from the start state, so it's valid. Yep. So what's the first modification? First modification to what we were doing before.
Multi-sets.
Multi-sets. Yeah.
Right.
And then, how do we count the number of parse trees? So, what is this arrow thing? We're drawing what?
Derivability relation.
Yeah, it's things you can get to from the start state, right?
Right.
Which is the whole point of a CFA, right? You take the start state and you do derivation rules, and if you get to some substring, that's in the language, just by definition, right? Like if I can reach things from the start state, by definition, whatever I'm working with,
Right.
all of the ways I could go from now on are in the language.
Right.
Which is why if there's 3 things here,
Mhm.
I can go any of the 3 directions because I got here from the start state.
Right,
So
right.
any of these 3 options are valid and in the language just by definition.
Right.
Does that make sense?
Mm-hmm.
Cool. But if I had 3 options here, that doesn't affect anything because I
You
can't
never
even
reach
get
it,
here
yeah.
from the start state. So it's not in the language.
what if both say S maps to C and A and C, yeah? So what if like A and C both have 2 in them?
If
If
A
they both had 2 in their like
and C,
that was
which
the
is
length
what do
of
you
the
mean?
multi-set.
Which A and which C? This?
Yeah, that A.
This has 2, okay, which is essentially saying there's 2 things that generate the terminal. Well, let's not worry about this particular
Yeah.
example much, but 2 things here, and where's the other stuff?
And there's 2 things in C.
Here?
Yeah.
So it's hard to say because depending on which variable you pick, the arrows might go different places.
Okay.
Which actually good.
Wouldn't it
Yeah,
just be
yeah.
4?
Because notice that's what I was trying to point out with my example of if I have 3 variables here versus 3 variables here. Both are reachable from the start state, but one is reached from the start state by 2 different branches, and the other is reached only by 1 branch. So basically what is the number of
I think
times
4 makes sense.
Hmm?
I think it makes sense that there would be 4
If it's here.
parse trees. No, if there were 2 in A and 2 in
It
C.
just means if you have 2 variables.
2
like,
in A and 2 in
underneath-
C. Well, this would
You
go up to
create
4
4.
immediately. And then here, if there's 2,
Why would that go up to 4 immediately?
because both trees, there's 2 parse trees, and both go through here.
Oh, I see, okay.
So it goes up to
Yeah,
4.
we were just thinking like 1 tree. But
One
yeah.
tree, yeah. I was looking at 1, but that makes sense.
And then here, well, this one's only reached by one of the trees, right? This one isn't even reached by the other. It's bypassed
Mm-hmm.
by the first tree. So we'd have 4 because this has 2 options. And then this having 2 options brings us to
6. But then
No.
more
5.
depending
It's,
on from
so
those
we
2
have-
branches.
sorry, 6 is 6 right? 6 is right. Yeah, sorry.
6, but then the,
Because there's 2 base, so this is only gotten to by the second parse tree,
exactly, yeah.
right? And gives 2 options for the second parse tree.
Yeah.
But then this gives another 2 options for the second parse tree.
Oh, but wouldn't the second parse tree also map to something else too then? Because like if S goes to A and to C, but S also goes to like A and goes to B.
Yeah, I don't care where
It'd be
the-
like 8 then, right?
Well, I don't know. I mean, like you could have another variable that actually goes to these same things, right? Like I could just
Oh, I
put
see.
a Q here that also leads to SS,
Okay.
and it's still technically a separate parse tree, right? But so that would multiply the number of cases by 2 for this, and then this would be an independent 2 other parse trees, like 2 parse tree options for that. So it's 2 times 2 times 1, like 2 times 2 times well, just basically 2 times 2.
So
So you
just
get
need to
4 for the
generalize
second
that,
parse tree and
right.
2 for the first parse tree, which
Yeah,
gives
I
you
see.
6.
So it is kind of recursive then, right? It's like it's a tree.
What
you
is
start with
the-
the number of trees that are possible at the top layer? Then you like map down to the next layers, and you check how many are possible under there. Like add them up, right? So then you know there's 6.
You don't
trees possible.
strictly multiply
further
them
down.
though, right? Because once I got here, I knew there were 2 parse tree options. Here, there's 2
Or you
parse
go
tree
until
options.
you know that a tree isn't real, and then you go back up and then delete that tree.
It's definitely recursive. Like recursive is the right way to think about it. But all I'm trying to note is that like once you have 2 different parse trees up here, you consider their number of possible parse trees each creates independent of one another, essentially. Right? Because this gives you 4 parse trees right out the gate, but I don't want to multiply that 4 by 2. I only want to multiply like half of that 4 by 2, because it, like, do you see what I'm saying? Sorry.
Why?
Let's go back. Think about it like this. There's 2 parse trees, right?
Okay.
The 2 parse trees I have drawn up here.
Okay.
If I say there's 2 options here, there are 2 options for the first parse tree and 2 options for the second parse tree.
Yeah.
So it's 2 times 2, right? Equals 4. When I say there's 2 options here, though,
There's only 2 for one of the trees.
right.
So it just adds to.
So this is why recursive is probably the right way to think about it, right? Because you want to
wanna
consider this.
separate each tree. That's why I was confused
yeah,
why
yeah.
you were saying that A has 4 at first. Because they're like, why does A have 4? Because
Yeah.
I'm only considering one
You're
of the
right.
trees.
Yeah. Your way is a better way to think about it. I guess I just wanted to be clear if there were 2 options for A that overall you'd immediately have 4 total.
Yeah, because if
Yeah,
there's
yeah.
2 options for A and 2 options for C, but then there's also like a B later, then one of the trees would have 4, the other one would have 3. Because there'd be 2 in A and like 1 in B. Or like 1
Yeah,
variable
yeah,
in
yeah.
that area.
Yeah. If you have like, you just got to consider them separately because one could have 4 options, the other could have 1 option.
But like, what if that like bottom, the bottom corner piece was like A, and then it was also like a variable that it's not included in S, so you can't create S with that variable. Then there's no parse tree, right?
It's not that you don't create.
You only consider the variable that
You
counts.
only consider things that are reached from the start state.
Okay.
If it's reached from the start state, though, you have a definitional guarantee that what you have reached, where you're at, is in the language. It
Okay.
doesn't matter what branches you take from now on, right? Because if I'm like, let's say I go from S to AB, is the string I'm going to generate in the language?
Yes.
What if I go from S to BA as my first step? Is that in the language?
Yes.
It doesn't matter what they generate. Like, it doesn't matter what future steps I
It just
take
needs
here.
to be reachable
I just
from
yeah,
the
it
start.
just needs to be reachable
That
from
makes
the start
sense.
state. Does that?
When you say start state, do you mean the top of the
Top.
pyramid?
Yep.
Yeah.
That's the start state.
And then we're running this algorithm on the example thing that they gave us, and that's it. But with
Well, no,
right.
multiple variables.
We're
things.
specifying nicely what the algorithm is, and then we're running it on the.
Yeah, so-
how do you,
draw a bunch
how
of
do you
different parse trees.
suggest?
Well, first, I definitely recommend mentioning multisets.
Okay.
That I recommend reading Cozen's description, and if you need intuition, looking back at this,
Mhm.
because Cozen's description is formal, and it will be easiest to write up in that manner. If you try and write it up in English, I pity you. Right? I mean, it's just gonna be huge, and it's hard to stay formal.
Mhm.
Whereas his is very nice. Like when you write it like this, it's all kind of simple. It's like, okay, I want to start by considering thing xi and xi plus 1s for all of the x for I from 0 to,
And then do this
5.
all the way up n times.
and then
the time.
next now I want to consider x sub I comma I plus 2.
Yeah.
And how I do that is I look at xi xi plus 1 and xi plus 1 xi plus 2, right? And concatenated together. You know, it's elegant. And then you don't add things to a set anymore. You don't add valid solutions to a set. You add them to a multiset,
Mhm.
which is going to be important, right? And then when you do this whole counting back down, you just branch and do this recursive.
Can we just write, we use Cozen's algorithm, but like,
Yeah.
Yeah.
If you wrote that like you use Cozen's algorithm, but instead of storing them, like whatever you call
One
it,
in each,
valid
yeah.
paths or something,
Oh, okay, I see.
or valid variables for generating this as in a set, you store them in a multi-set.
Yeah.
Yeah, I mean that would be a reasonable thing to do. You may want to also modify his algorithm though by like storing where you got that element from. Doesn't even need to. There's infinitely many ways to do this. It's hard to give good advice on this because I think everyone will prefer something different.
Well, does it matter where you got the element from? Because couldn't you technically create that element with some other combination of stuff?
So if you like, this is the thing. You don't have to use multi-sets, and there's a couple ways to get around it. One is when you're drawing these arrows, you just check, okay, where did I get S from, and you recompute for each of these. Was S generated by any of these, right? But that seems like you're kind of just doing all the work over again. You could also not get away from multi-sets by storing elements as I could store an S.
You just
in it.
write AC.
Let's say at the top layer. No, bad idea. I like the idea, but like it's this way I think will be nicer, which is we store it as like I'm gonna erase this. So like consider this one, right, which had two options. We could have stored this as S sub X 0, 1 as the pair x0, 1, x1, 6. And we just specify that this has all the same rules as S. Like, right, we will later treat this as an S, but we can differentiate it from S, X, what's the other one? It's going to be 0, 4, right? And 4, 6.
Oh, that's actually really pretty.
And now we can just directly reference them.
Yeah.
So we could just store it as get away from this whole multi-set thing and do it this way. Because then when you're writing the algorithm, you just call these you can like call these variables, right? You can give these names and use them again.
And then you jump into each of the two.
Yeah,
The
and
recursion.
then you start counting.
Which is why I was saying.
And so
this
you
is
can do
really
your whole
nice.
recursive counting thing, and you know exactly where to go.
So
right?
then you jump to that square.
This is
that-
the example. This is
the
what I was saying
coordinate for
earlier of
whatever.
drawing the arrows as you put elements in.
Yeah.
Right? That's what this is equivalent to.
Yeah.
Is instead of storing things in a multi-set, you store them in a set, but you might have like S multiple times. It's just its subscript will be different. Yeah.
Okay.
So I think that's probably the most elegant way coming to mind right now.
Solid. Okay.
It's gonna be fun.
Makes sense.
Kids have fun.
A quick question, just to clarify.
Yeah.
It says to count the number of parse trees of a given string and to construct one if the number is non-zero. Does that mean we can't construct the trees before? Like,
What it means is if the number of parse trees is
Yeah.
greater than, for that string, is greater than 1, give one of them, right? Is that what it means? Can you read it? Sorry, can you read it one more time?
so it's like, it
Okay.
won't be correct.
Modify to count the number of parse trees of a given string and to construct one if the number is non-zero. Fine. Okay, yeah. It just means your algorithm should output one of the parse trees. It should figure out the number of parse trees and output one of them. So you could just arbitrarily pick any of the paths,
Right.
right? And it needs to output
Oh,
it.
this is a long homework.
I look forward to grading it.
Does this mean there are two parts and we can get 20 points for this?
Yeah, I'm confused.
Probably not. I don't know. I mean, on the bright side, and if you did really poorly or just skipped it entirely, you drop 1. I don't do the format. I just write the numbers.
Cool.
Yeah, some homeworks are significantly harder than others. I will acknowledge that.
So
fact.
for the last homework, I just didn't see the second
I
problem.
think okay, I said I beat this to death like a half hour ago, but I guess now I think I've actually beat it to death, so I'm gonna stop.